There may be a number of different IT staff managing devices, but not all of them actually need a Jamf Pro account. There are some creative ways we can allow staff to update device inventory records without ever logging into Jamf Pro. Here's a good example. There's a supply of iPads designated as loaners for substitutes if a teacher calls in sick, or if an employee needs one while theirs is getting repaired. The staff member in charge of this stash has a lot of responsibilities, but using Jamf Pro isn't one of them. By making a policy available to them in self-service, we can write a script that prompts them for a serial number, then a status of that device. That information is then used to execute an API call to update the device's inventory record and move it to a different smart group so it receives the proper apps and settings, all without the staff member ever seeing Jamf Pro. This is Jeremy. Let's examine a couple ways to prompt users for input with a script. If you haven't already, we highly recommend checking out our videos on variables and the API in the Scripting and Advanced Scripting series. Before writing this script, it's important to understand the full structure of this workflow because it involves multiple areas of Jamf Pro working together. These areas include extension attributes, smart groups, scope, and policies, so we recommend checking out videos covering those topics beforehand if you're unfamiliar with any. First, a pop-up menu extension attribute needs to exist with different options for the device's status. Second, we need smart groups for when a device's status matches each of those options. These can be used for scoping apps and configuration profiles. Lastly, the script we create can be made available to the staff member in charge via a policy in self-service. When writing the script, I'm going to begin with the API call, since it's doing the work for us to make changes in Jamf Pro. Taking a look at the classic API resource documentation, I'm trying out a get mobile devices by serial number. Now I've got the request URL and need to find where the extension attribute is located in the XML response body. Using the Find feature in Safari, I can search for extension and see the extension attributes are the last element within the mobile device element. More specifically, the loan status extension attribute has an ID of 4 and the value is currently empty. With that information in hand, I begin the API call as usual with the curl command, specify user credentials, enter the request URL, specify XML as the content type with a header, and define the request method as a put. Next, the data we want to send includes a start tag for the mobile device element, a start tag for the extension attributes element, notice the S to make it plural, then a start tag for an individual extension attribute element with an ID of 4. With the ID element closed and the extension attribute element still open, add a start tag for the value element and enter one of the possible choices from the extension attribute pop-up menu. I'm using Ready to Loan. Finish the API call by closing the remaining open elements with end tags, then test it. Looks like that was successful, and we can confirm by checking the device's inventory record. Now we need to replace the serial number and extension attribute value with variables that get defined earlier in the script using command substitution. Starting with the serial number, we can use AppleScript to prompt users with a blank text field, and whatever they enter will be used as the serial number in this script. Apple provides some great examples of this in the Interacting with Users section of the Mac Automation Scripting Guide, like this one in Prompting for Text. We can even use this link to open the AppleScript example in the Script Editor app. Clicking the play button runs the script so you can get an idea of what it does and how it works. Cool, so it's setting what I type as a variable called the response, then displaying another dialog that uses what I type by showing the text returned of that variable. Let's modify this to something that better suits our needs. Change the question to something like, please enter your serial number. Leave the default answer blank. I'm removing the note icon, and the options for buttons look okay to me. The second line is an example output for the first line, so we can get rid of that. This last line displays another dialog, which I don't want to happen yet, so I can remove that. However, notice how it recalls the variable with the text returned of the response syntax. Instead of setting and recalling a variable, we can begin the first line with text returned of and place the whole display dialog command in parentheses. Run this script to test it, and the result is the text that was entered. Next, we need to get this AppleScript to run as a part of the Z shell script. This can be achieved with the OSAScript command, but instead of using the -e option, I'm using a here document. A here document uses a form of redirection, most often indicated by two left angle brackets, where a block of code is used as the standard input for a command, in this case the OSAScript command. This can be incredibly helpful because AppleScript uses special characters differently and they would need to be escaped properly in order to work in the Z shell script, but this isn't necessary with a here document. The syntax continues with a limit string following the angle brackets. A limit string frames the code block, so we'll need one at the beginning and end of our AppleScript. The limit string could be any string of text, but should be something that won't occur anywhere in the code block and break things. It's oftentimes something like EOF, which stands for end of file. On the next line, paste the AppleScript from script editor and enter the limit string again on the line below that. Finally, on a line below the second limit string, end the command substitution with a right parenthesis. This can be tested by commenting out the API call and adding a quick echo $serial number in double quotation marks to see if that variable is getting populated correctly. Boom, that works. Back in the Mac Automation Scripting Guide, check out this example for prompting users for a choice from a list. This is exactly what we need to provide a user with options from the extension attribute pop-up menu. Select Open in Script Editor and run this script to see it in action. The first line sets a list of choices. The second line sets a variable based on what the user chooses from a prompt with the list of choices. And the third line prints the variable from the second line. Again, we can modify this to better suit our needs by changing the first variable to something like EA options and entering each potential option in double quotation marks separated by commas in the braces. On the second line, I'm changing the second variable to EA selection, and be sure to modify the other variable on this line to match the variable from the first line. Then change the text for the prompt and the default item. On the last line, change the variable to the one created on the second line. Run this again for testing, and the result is the option that's selected from the list. Now we can use this AppleScript to populate a variable in the Z shell script like we did before with command substitution and a here document. I'm using EA value as the variable equals $left parenthesis to begin the command substitution, then the OSAScript command, and a here document with EOF as the limit string. Paste the AppleScript from script editor, then enter the limit string on the next line, and a right parenthesis on the line below that to end the command substitution. I'm commenting out the first part of the script and adding an echo $EA value in double quotation marks to test that variable. Running the script displays the prompt, and my selection is printed as the result. Great, now we have two variables we can use in the API call that are populated based on user input. Go ahead and uncomment any necessary lines and remove anything added for iterative testing, and let's run this whole script. First, I'm prompted for a serial number, then to select an option from the list. The script uses those pieces of information to execute an API call and update the device's inventory record. We can confirm this works by checking Jamf Pro, but the person that will be interacting with this script doesn't have access and would probably appreciate some sort of confirmation message. Since we've been using AppleScript to display prompts, let's do one more. In a script editor window, secondary clicking brings up a number of templates including dialogues. Select the dialog one button OK template, and we can use the variables from the Z shell script to display something like $serial number moved to the $EA value group. Back in the Z shell script, I'm using the OSAScript command and a here document, then pasting the AppleScript between the limit strings again. Run this script, and now there's a prompt at the end with a message showing the device with the serial number provided was moved to the group that was selected. Now all we need to do is save the script and upload it to Jamf Pro. From there, we can make a policy that runs the script available in self-service, scoped to the staff member in charge of the loaner iPads. This way we can be sure iPads that are loaned out have the proper apps and restrictions without giving Jamf Pro access to a user who is unfamiliar. Sure, there's more we could add to the script to check if the serial number entered is valid or if the API call is successful, but hopefully this gets you started and provides a good base for a workflow you can tweak to solve other issues. That's all for this video on scripting. Be sure to check out other Jamf Pro training modules. Thanks for watching.